This section looks at DHCP protocol principles in support of automatic address allocation within the enterprise. An enterprise network may often consist of a substantial number of host devices, each requiring network parameters in the form of IP addressing and additional network configuration information. Manual allocation is often a tedious and inaccurate business, which can lead to many end stations facing address duplication or failure to reach services necessary for smooth network operation. DHCP is an application layer protocol that is designed to automate the process of providing such configuration information to clients within a TCP/IP network. DHCP therefore aids in ensuring correct addressing is allocated and reduces the burden on administration for all enterprise networks. This section introduces the application of DHCP within the enterprise network. So upon completion of this section, it is generally expected that trainees will be able to describe the function of DHCP in the enterprise network, explain the leasing process of DHCP, as well as configure DHCP pools for address leasing. When dealing with networks that host a large number of users, it becomes increasingly difficult to ensure that the IP addresses assigned to users are unique and configured correctly within each end station. At times, there is the possibility that addresses are configured as part of the wrong network, or incorrectly, that results in duplicate addresses being present within the network. It is for this reason that networks hosting a large number of end station devices do not rely on manual allocation. More so, within a fast-changing enterprise, it is commonplace for users to move from one location to another, and so network addressing must be flexible and adaptable. DHCP is the standard application for dynamic management of addresses and works on the principles of a client-server architecture over which requests are made and IP addresses are assigned. DHCP is capable of supporting the allocation of addressing using one of three different mechanisms. The first of these is manual allocation that allows an end station's IP address to be determined by the network administrator but is allocated using DHCP. Another mechanism is automatic allocation, in which an address is assigned to an end station by the DHCP server and becomes permanently associated with that end station, which is useful when wishing to maintain association without having to manually specify addresses. The final and most common type of allocation mechanism is the dynamic allocation. This involves an address being leased to an end station for a given period of time. When the lease period expires, possibly due to the end station no longer being active in the network, the address can be returned to the DHCP server, which can then be assigned to another end station. The actual allocation of addresses relies on a number of messages. These messages represent the stages of communication that the DHCP client or end station and the DHCP server go through in order to successfully allocate addresses. The initial DHCP messages originate from the client in the form of the DHCP discover message that attempts to locate DHCP servers from which an IP address can be leased. Once one or multiple servers receive this message, they respond to the client in the form of a DHCP offer message. This message will contain potential configuration information that is reserved by the DHCP server while the allocation process takes place. If the client likes what it sees, it will send a DHCP request message approving an offer from one of the DHCP servers. All other servers will as a result be implicitly declined and will cease to reserve addresses for allocation. A DHCP ACK message is sent by the DHCP server and confirms the allocation of the address and any other parameters that are carried. In some instances, though, the server may return a DHCP NAK, particularly where a leased address is attempted to be renewed by the client. It may be that the address lease is unable to be renewed due to, for example, the DHCP server no longer assigning addresses for that network. Leased addresses that are no longer required to be assigned to an end station will see a DHCP release message being generated to inform the DHCP server that the remaining lease is to be terminated. The DHCP server allocates addresses from a range of contiguous addresses, known as an address pool. These address pools can be assigned on a per-device basis or per interface, and are respectively known as global and interface address pools. We show here an example of the two address pools, the first being the pool associated with the interface, for which the addresses in the 10.1.1.0/24 range have been assigned, while a second global address pool known as pool 2 here with a 10.2.2.0/24 address range has also been created. Interfaces can be associated with either pool, which is determined by a DHCP select command, in which either the global or interface parameter is selected. We represent here the communication flow of the DHCP client and server in order to achieve the allocation of IP addresses. This begins with the DHCP discover message that is broadcast by the client to discover a DHCP server that is capable of allocating an address. The client will at this point generate a unique transaction ID that will be used to bind the DHCP messages. Any message that is received that does not contain this specific transaction ID will be silently discarded. The DHCP discover message broadcast by the client may be received by one or multiple DHCP servers that will proceed to generate a DHCP offer for the client. Whether a reply is sent as a broadcast or a unicast comes down to whether a broadcast bit is set in the DHCP message header. Typically, however, we find that this broadcast bit is not set in VRP, and DHCP offer messages are sent as unicast. The client will accept the DHCP offer based on the first offer received, where offers are sent from multiple servers. The offer is responded to with a broadcast message in the form of a DHCP request, and a server ID in the message represents the server from which the offer is accepted. All other servers will take the DHCP request containing another server's address as rejection of their offer. The reference server, however, will proceed to confirm the use of the address, following which the client will initiate gratuitous ARP to verify that the address is unique in the network. A client that is allocated an IP address by a server will maintain that address for a lease period. The default process requires that when only half of the lease period remains, the client is expected to initiate a DHCP request, which in this instance is sent as a unicast message, in order to renew the lease. The DHCP server is expected to reply with a DHCP acknowledgement, which confirms the lease renewal. There may be instances where requests for renewal of the lease go unanswered by the DHCP server, due to changes to the server or as a result of the server's absence from the network. When only 12.5% of the lease period remains, however, by default, the client will proceed to send DHCP request messages as a broadcast in an attempt to find the server. The client may receive a DHCP ACK or DHCP NACK message. In the case of a DHCP NACK, the client will return to an initialized state and begin once again the process of IP address acquisition, in which a new IP address is requested. Clients that are unable to renew their IP address before the renewal period expires are required to release the address back to the DHCP server. This DHCP release message is transmitted as a unicast. The allocation of a new address will see the initialization process once again occur. We look here at how each of the two forms of DHCP pools are configured, starting with the interface pool configuration. As with all implementation of DHCP, the DHCP service must firstly be enabled in VRP. The interface view is accessed for the interface to which the DHCP pool is to be allocated. In order to ensure that the interface uses the address pool, the DHCP select interface command is applied. Other information, such as the DNS list, represents other configuration information that is carried in support of allowing the DHCP client to automatically learn other information such as the DNS server. Addresses that are assigned from the pool range and should not be used by the client should be excluded from the address range. We see here that the address 10.1.1.2 has been excluded from the range since it is currently allocated to a domain name server. The lease period by default is set to 1 day. However, we show here how this can be altered if required. Using the command display IP pool interface gigabit Ethernet 0/0/0, where the interface itself represents the pool name here, we are able to view the details of the DHCP configuration for the interface. The main changes include the lease period, configured to 3 days, the configured DNS server address, and also the current gateway, which relates to the gigabit Ethernet 0/0/0 interface. The statistics at the bottom represent the pool range from 10.1.1.1 through to 10.1.1.254, for which a single address has currently been assigned, and from the disabled stats we can understand that one address has been excluded, and that being the address 10.1.1.2, leaving 251 idle addresses of the 253 host addresses available. In comparison, we can take a look at the means of configuring a global address pool. This again involves the enabling of the DHCP service, if it is not already active, and the creation of a pool. Once the pool is created, a pool range is assigned using the network command under the IP pool view. The gateway list defines the IP gateway address that should be used by the client, and additionally we have a lease period of 1 day, which happens to be the default lease period. Under the interface via which host B is reached, the command DHCP select global is used. This defines that the interface should associate with the global DHCP address pool. We show in this instance a summarized version of the pool information using the display IP pool command. From here, we're able to identify all pools that have been configured. However, for simplicity, this only reflects the current global pool. The associated parameters can be seen, including the gateway address and mask for the network. In terms of address allocation, we can again see that a single address has been allocated by the DHCP server, and since this time no address was excluded for other uses, the disabled stats show a result of 0. So in summary for this section on DHCP, we just have a couple of questions here. The first asks, which IP addresses should generally be excluded from the address pool? Well, IP addresses that are used for server allocation, such as any local DNS servers, should be excluded in order to avoid address conflicts. And what is the default IP address lease period? The default lease period for DHCP represents a period equal to 1 day.